Hello, my name is Irfan Husaini. We are from group A1I. So today we will present about statistical analysis on passenger satisfaction with LRT service. Public transportation plays a vital role in ensuring mobility, especially in urban areas where congestion and environmental concerns are growing. One of the key indicators of a successful transit systematic passenger satisfaction, which reflects how well the service meets user expectation in terms of reliability, safety, accessibility and comfort. This study focused on the light rail transit, that is LRT system, a popular mode of transport for daily commuters. Using dataset from a recent passenger survey, we conduct a series of statistical analysis to explore the factors that influence satisfaction levels among LRT users. Specifically, we examine whether satisfaction vary across demographic groups such as gender and education level, and whether passengers felt differently about specific aspect of the service such as facility quality, safety and timeliness. A combination of parametric and non-parametric tests including t-test, chi-square test and the Kruskal-Wallis test were used to analyze relationship between variables. This approach provides both general and detailed insights that can help LRT service providers better understand the needs and the expectation of their passengers and identify areas for improvement.
Hi, my name is Yusuf. I will present for question E. The first aim. The aim of this analysis is to examine whether the age of LRT passengers is normally distributed. So to do this, we use Google Sheets to create a normal probability plot. So we will follow the steps. First step is we combine the age data of both male and female passengers. Then we sorted it in ascending order. Then we calculated the percentile rank for each age value. So based on each percentile, we computed the expected z-score using the formula which is equal norm.s.inv in bracket percentile. Then finally, we created a scatter chart where the x-axis show the actual age value and for the y-axis show the expected z-score from normal distribution. And then for interpretation, from the scatter plot on the right, we can observe that the points roughly form a straight line. This tells us that the age distribution of LRT passenger is approximately normal. Okay, next for the question 1b, test mean age by gender. To check whether there is a significant difference in the mean age between male and female LRT passengers, we perform a two-sample t-test assuming equal variances. Okay, the first step, we first sorted the age data of both male and female in ascending order. Then we identified the sample size, which is 40 male respondents and 100 female respondents. So we calculated the mean age for each group. For male, we got 25.43 years, and for female, we got 27.49 years. Next, we calculated the variances, which is for male, we got 51.48, and for female variance, we got 41.85. Using this, we calculated the pool variance, which came up to 44.57, and then we used the t-test formula to calculate the t-statistic, which was, we get negative 1.9475. And finally, we calculated the p-value, which was 0.0535. So, based on this calculation, since the p-value is greater than 0.05, so we fail to reject the null hypothesis. So this means that there is no statistically significant difference in mean age between male and female respondent at the 5% level. However, the result is very close to being significant, so with a larger or more focused sample, we might detect a potential difference. Okay, next for question 1c, probability that the sample mean age more than 26.06. Next, we wanted to calculate the probability that the sample mean age is greater than 26.06 years. Okay, so we were given a population mean of 26.9 and the sample mean is 26.06 and the sample size, which is n, is 140. We calculated the z-score, which came up to negative 1.48. Okay, using the z-score, we found the corresponding probability to be 0.9306 or 93.06%. This means that there is a 93.06% chance that the sample mean age is greater than 26.06. Okay, as you can see in the figure below, it shows that a Z distribution sketched with the shaded gray representing the 93.06% probability to the right of Z, which is Z equal to negative 1.48. Okay, now let's move on to question 1D, which asks about the probability that the sample mean age falls between 23 and 25. To answer this, we converted the raw value to Z-score. For the value 23 and 25, the Z-score are extremely low, which is negative 0.88 and negative 3.35 respectively. Using the standard normal distribution, the probability corresponding to this range is only 0.0004 or 0.04%. This is very small percentage, tells us that it is highly unlikely or almost impossible for the sample mean to be between 23 and 25. In the Z distribution sketch below, you can see this visually. The shaded area on the far left of the curve represent this tiny probability. This emphasizes how rare such a sample mean would be under normal conditions.
Hello, my name is Irfan Husaini. Today I will be presenting our findings for question 2, which explore patterns in passenger satisfaction with LRT service using dataset A. Our focus was on two areas. First, whether passengers felt differently about specific LRT facilities, and second, whether satisfaction levels different between male and female passengers. So let's start with the first part of the question. we want to compare how satisfied passengers were with two key aspects of the facility quality. One was disabled friendly features known as FQ2 in the dataset, and the other one was the condition and maintenance of elevators and escalators, labeled as FQ3. To measure satisfaction, we look at the number of passengers who gave a rating of 4 or 5. These ratings represent passengers who are somewhat satisfied or very satisfied. So we use them as our criteria for satisfaction. When we analyzed the data, we found that about 62% of passengers were satisfied with the disabled friendly features, while only 48% were satisfied with the elevators and escalator. This already suggests a noticeable difference in perception between the two items. But to determine whether this difference was significant and not just due to chance, we construct a 90% confidence interval for the difference in proportion. The result was a range from 4.41% to 23.56%. And since this range doesn't include zero, it tells us that the difference is meaningful. In other words, we have solid evidence that passengers are more satisfied with the disabled-friendly features than they are with the condition of the elevators and escalators. This insight can help LRT management identify where improvement are needed most. The disabled-friendly features seem to be performing well and should be maintained, but the lower ratings for elevators and escalators suggest that passengers are experiencing issues in that area. So, if the company is looking to improve overall satisfaction, focusing on better maintenance or upgrades for these facilities could be a good place to start. Okay, so for the question 2, the result show that female passengers had an average satisfaction score of 3.33, while male passengers had a slightly higher score of 3.48. While this might look like a small difference, we need to determine if it was statistically significant. So, we performed a one-tail independent t-test at the 5% significant level. The result gave us a p-value of 0.1594. Since this p-value is greater than 0.05, we failed to reject the null hypothesis. This means there is no strong statistical evidence that female passengers are more satisfied than male passengers. Even though male passengers had a slightly high score, the difference is too small to be considered meaningful from a statistical perspective. So, to summarize the findings, first, we found a clear and significant difference in satisfaction between the two facility features. Passengers are more satisfied with disabled-friendly features than they are with the elevators and escalators. This suggests a specific area for the company to improve on. Second, we found no significant difference in satisfaction by gender. Both male and female passengers report fairly similar levels of satisfaction overall. This insight, although look simple, can help MFC management make better decisions when it comes to improving service quality and prioritize upgrades. So this is all for me. So we move to the next person.
Okay, move to the question 3, parametric hypothesis testing. For the research question, I choose transportation survey data, statistical analysis of user demographic and satisfaction. ANOVA, does education level significantly affect transportation satisfaction score? Education background may influence service expectation, quality awareness, and satisfaction threshold due to varying socioeconomic, cultural, and lifestyle requirements. For the data set overview, we have 142 survey participants and 5-point like scale to hypothesis test. For the hypothesis, for the H0, no significant difference in mean SS4 score across education levels. For the H1, at least one group mean differs significantly from the others. ANOVA justification: why ANOVA over multiple t-tests efficiently compares all three groups simultaneously while controlling type I error rates and maintaining greater statistical power. Education level represents meaningful demographic distinction, while SS4 provides standardized certification measure with sufficient variability for parametrics analysis. For the 11th test for homogeneity of variance, the research question I choose: do males and females exhibit equal variance in their frequency ratings? The purpose of this research is investigating potential gender differences in rating consistency and validity homogeneity assumption for parametrics analysis. Okay, for the hypothesis, for the H0, equal variance between gender group. For the H1, unequal variance between group. Okay, for the data in here, the male we have a 6N with the male with 3.60, standard deviation of 0.42, we got variance of 0.267. And then for the female gender, we have 14 and with 3.57 mean and 0.85 standard deviation. We got 0.725 variance. For the Levin justification, essential assumption validation for parametric produce and greater robustness to normally departure than F test, particularly suitable for Lakers scale data. Okay, that's for question 3. Thank you.
So hi, I'm Jose. I'm going to analyze question 4. For question 4, I will present the three parametric tests and explain why selected specific variable for each test. I use the parametric method because our satisfaction data is 1 to 5 scales, which are all the category non-normal numbers. Also, demographic variables like gender and education category that's cannot use regular statistical tests. For the three-scale test of independence, I studied the gender and three purpose because both are category variables and measurements. When understand usage patterns, the text examines whether these two variables are independent. My result shows chi squared equals 2.9672 with p equals 0.397, which means I failed to reject the null hypothesis. This tells the male and female passenger has similar three purpose partners. Both groups use salary equally for school, work, and leisure trips. For the Madam Within You test, I compare the FQ of satisfaction between gender because this test works well for older data with two groups. FQR measures satisfaction with disability-friendly feature, which is important for inclusive deadline. My results show U equals 1,649.5 and P equals 0.085. So I feel to reject the null hypothesis. This means accessibility feature works well for all passengers regardless of gender. For the cruise go well test, I examine PR3 safety satisfaction across 3 education levels because this test handles multiple groups with all the outcome. Safety perception is critical for police decision. My result show H equals 4.3 with P equals 0.116. So I feel to reject the null hypothesis. All education groups show similar safety satisfaction score across high school, bachelor's degree, and graduate levels. The key finding across all 3 tests is that demographic factors do not significantly affect service satisfaction. This suggests LRT has achieved good service standardization across different passenger groups. That's all of my question. Thank you for your listening and patience.
So next, we will talk about key finding. So our first key finding, we found that the age distribution of LRT passengers is approximately normal. This was observed using a normal probability plot where the data points closely follow a straight line. Because of this, we were able to use parametric tests like the t-test for the further statistical analysis. For the second, we compared the average age by gender. We found that male respondent had a mean age of 25.43 years, while female respondent had a mean age of 27.49 years. So on average, female passenger in our sample was slightly older than the male passenger. And for the third, we tested whether this difference in age was statistically significant using a 2-sample t-test. The calculated t-statistic was -1.9475 and the corresponding p-value was 0.0535. Since this p-value is slightly above 0.05, so we failed to reject the null hypothesis. This means there is no statistically significant difference in mean age between male and female LRT passengers at the 5% significance level. So in summary, although female passengers were on average older, the difference isn't large enough to be considered statistically significant.
For question 2A, our analysis found that passengers are significantly more satisfied with disabled-friendly features FQ2 compared to the condition of elevators and escalators FQ3. About 62% of passengers report satisfaction with FQ2, while only 48% felt the same about FQ3. The difference in satisfaction is nearly 14% and the 90% confidence interval ranging from 4.41% to 23.56% confirms this difference is statistically significant. This suggests that MFC should consider prioritizing improvement to elevator and escalator facilities to boost overall satisfaction. For question 2B, we test whether gender affects satisfaction. Male passengers had a slightly higher average score than females, 3.47 versus 3.34, but the difference was not statistically significant with a p-value of 0.264. So we conclude that satisfaction levels are similar across genders and gender doesn't appear to influence how passengers rate the service. Next, one of the analyses we conduct was to test whether trip purpose is influenced by gender. In other words, we want to see if male and female passengers tend to use the LRT system for different reasons, such as commuting to work, going to school, travelling for leisure or other purpose. To explore this, we use the chi-square test of independence, which is commonly used to determine whether there is a relationship between two categorical variables. In this case, gender and trip purpose. The test result in a p-value of 0.397, which is significantly higher than the usual significance threshold of 0.05. This tells us that the result is not statistically significant, and we must fail to reject the null hypothesis. Simply put, there is no meaningful association between gender and the reason for using the LRT. Both male and female passengers in the survey report similar trip purpose, with many of them commuting to and from work or school or travelling for leisure. Another part of our analysis looked at whether education level influence how safe passengers feel when using the LRT. For this, we use the Kruskal Wallis test, which is a non-parametric test used to compare satisfaction score across more than two independent groups in this case. Different levels of educational attainment. The satisfaction measure we used was PS3, which represent passengers' rating on safety and security. The result of the Kruskal Wallis test gave us a p-value of 0.116, which is higher than the 0.05 significant level. This means the difference in safety satisfaction scores between the education groups were not statistically significant. In simple terms, regardless of whether passengers were high school graduates, degree holders, or had postgrad qualification, their feelings of safety while using the LRT were quite similar. So, we can conclude that education level doesn't appear to influence how safe passengers feel, which suggests that perceptions of safety are consistent across different educational backgrounds.
Hi, I'm Consulia. Next, I'm going to do some simple conclusion and then do some recommendation for our study. So first, what does this data tell us? Our statistical analysis using t-test, ANOVA, and T-score tests consistently show the same result. Passenger demographic don't significantly affect LRT satisfaction, with all p-value above 0.05. We fail to reject the null hypothesis across demographic comparison. This strong statistical evidence proves that age, gender, and education directly impact satisfaction partner. Both parametric and non-parametric tests confirm this, making our finding reliable. So our recommendations are clear. First, prioritize elevator maintenance because the 90% confidence interval confirms a real 14% satisfaction gap. Second, implement standardized improvements since demographic difference aren't significant. Third, continue using this proof and statistical method for monitoring. The bottom line, our beauty method validation shows that operational excellence, especially elevator maintenance, is the most evidence-based strategy for boosting passenger satisfaction. The concludes our comprehensive analysis for LRT passenger satisfaction. Thank you for your attention, and we welcome any question you might have.